In this video, we'll be talking about broadcasting. Broadcasting is one of the more advanced features to Numpy, and it can help make your array operations more convenient. So by the end of this video, you should be able to employ broadcasting to perform operations on different size ND arrays. Suppose you have a multidimensional array A, and you want to add the elements in array B to each row of A. You've got a mismatch in the size of the arrays. To solve this, you will likely find yourself trying to figure out how to replicate B 3 times so you can do the computation that you want. This mismatch in sizes is the exact problem broadcasting aims to solve. Let's put some values in the matrix and in the array. And if you just add A to B, broadcasting will try to figure out which dimensions you want to add, and will automatically see that because of your number of columns in A matches the number of columns in B, it will effectively perform the computation you likely wanted. So A plus B will add B to each of the rows of A, producing this result. I will note that this is only for illustration purposes. B actually retains its original shape, and that's part of the beauty of broadcasting. Because B retains its original shape, no copying is involved. This is actually a very memory and computationally efficient operation. So before diving into the notebooks, let's go over the rules regarding broadcasting. These are the rules directly from the Numpy documentation. The rules likely follow your intuition. Between the two ND arrays, the dimensions either need to match or it needs to be a scalar. And it begins with the matching the trailing dimension and then works forwards. A scalar value also applies, as a scalar value has one row and one column, so adding a scalar effectively uses broadcasting as well. So let's dive back into the notebooks and see some examples. Now that we've seen broadcasting in principle, let's work through a few more examples. First, we'll create a 4x3 ND array and we'll fill it with zeros. Now we'll create a 3x1 array with the values 1, 0, and 2. And now we'll do the broadcasting. We'll add the 3x1 array to our 4x3 array, and we'll add the array add rows to each row of the start. Because start was pre-filled with all zeros, each row of start now contains the values in add rows. Let's do the same thing, except we'll add to each column this time. To do that, I'll need a 4x1 array, which I'll build as a 1x4 array, and then just use a transpose on it, denoted by T. Now I'll add this 4x1 array to start, and because I'm using broadcasting, I should get back the result, which has the values from add calls in each column of start. It's worth showing that our addition of a scalar value like 1 to start works fine, as it will broadcast in both directions. Broadcasting takes some practice and some patience. It helps to draw out the matrices when you work. I have the example from the video in the notebook below, and it might be a helpful place to start.